So on our bell work, does anybody have the answer to number 1? What do you have?
Okay, whenever you get the temperature, are you supposed to add? Okay, no, okay. 274. See, I told you it was hard. Shut up, Kalia. What? Kalia, tell us what. You need to do it. I gave you it.
Do I have a second on?
I'll second, just so she can.
Wait, me.
What?
477.9. All right.
Who said 203?
I did. Brendel did it.
203 is correct.
Hey.
Okay. Let's work it. Pete, you guys, I need you to focus. So 4 moles is what variable? At a pressure of 5.6. Oh, that is P. 12 liters. And I want to know T. So PV equal, it does not say what to have temperature in, so I would just stop at Kelvin. So P is 5.6. V is 12. N is 4.0. What's the value of R that we use?
0.0821.
0.0821. And T is what we're looking for. So T, you put that in the calculator, and we get 203, and our unit is Kelvin.
What the heck?
If you want to know. What?
All right. So I did the 5.6. I set it up just like that.
Uh-huh.
And then divided by that. And I got 204 point whatever.
Okay, that's fine.
But I thought we had to add 274.
No, because it doesn't say. If it was said in Celsius, then we would subtract 273. All right. If I have an unknown quantity, anybody have this answer? 1.25. Anybody second that? You have to. If you're seconding it, you have to actually be verifying it.
I am. I trust Brendel.
All right. A pressure of 1.2. So that's my P. The V is 31. T is 87 plus 273. So that's what? 360?
360.
So we use PERVNERT. PV equals nRT. 1.2 times 31 is equal to N times R. What's the value of R? 0.0821. And T is 360. So put that in the calculator. Tell me what N is. 1.25, and our unit is? If I asked for grams, what would we do?
We do that little multiplied by the molar mass.
Molar mass of whatever the compound may be. All right, a metal tank contains 3 gases, and they are oxygen, helium, and nitrogen. And we have 3.5 atmospheres of oxygen. So that's P of O2. 35, sorry. 5 atmospheres of N2. So that's the P of N2. And we have 25 of helium, and so that is P of He. What is P total? 65. Do I have a second?
Yes.
65 unit is what?
ATM.
Questions on how we got that one? So we just added them to get the total. Yes.
If it's ever like in torr,
Uh-huh.
convert it.
If one of them was in torr, then we would convert it, yes. All right. Blast furnace gives off unpleasant and unhealthy gases. If the total air pressure is 0.99 atm, so that's my P total, And the partial pressure of carbon dioxide is 0.05. And the partial pressure of hydrogen sulfide is 0.02. Then what is the partial pressure of the remaining air? 0.92. So we have 99 is equal to 0.02 plus 0.05 plus x. And x is 0.92. And the unit is ATM. Questions on that one? All right. So we're going to look at Graham's law of effusion. Let's quit texting each other. So the rate of phone's away. Just stop. You'd be better served writing rather than texting. The rate of effusion of a gas is inversely proportional to its square root of its molecular mass. So what that is saying is that the bigger the gas molecule is, then the slower it's going to be. And the harder it's going to be to pass through an opening. So I like to think of this as, has anybody ever seen Austin Powers?
Yeah.
And you know Mini-Me? Okay, and there's a part where Mini-Me's being chased by the big guy and he's saying, "Get in my belly," right? Okay, so they're all at the same temperature, right? And so what happens is, who is faster? Mini-Me or his friend that's chasing him trying to eat him? The small one. So that's just like it is with gases. The smaller you are, the faster you're going to travel, if you're all at the same temperature. Okay? So effusion is the passage of gas through a tiny opening. So if I were to have a balloon and I were to poke a hole through it really carefully, making sure not to pop it, and I let it take the pin out, then air is going to start escaping. And that air escaping is effusion. It's coming out of the balloon and into the room, and that is effusion, escaping through the pinhole. You run over a nail, you get a nail stuck in your tire, eventually your tire goes flat, and that is because the air inside your tire is escaping through effusion. Okay? Now, Graham's law also works with a diffusion, which is when we take two gases and they eventually mix together. So spray something over here, spray something over here, and eventually those right here, wherever, we're going to start smelling it, and that is diffusion. They come together, okay? So lighter molecules diffuse faster than heavier molecules when they're at the same temperature. If they're at different temperatures, then this does not apply. So here's our equation. The rate of effusion for gas 1. So please make note that gas 1 is my lighter gas. Gas 2 is my heavier gas. The lighter gas travels faster. So lighter has a faster rate. And the heavier has the slower rate. So this proportion is inversely proportional to the square root of the masses. So gas 2, we said, is heavy. Gas 1 is light. So we need the molar mass of those gases. Do the math, and we can figure out what the molar mass is of a gas based on its rate. So here I have ammonia. Ammonia is NH3, and it has a molar mass of 17 grams per mole. I take a piece of cotton, soak it in ammonia, put it in this tube. Then I take a piece of cotton and I soak it in hydrochloric acid, which has a molar mass of 36.5. And I put it at the other end of the tube. And those two gases are going to they're going to diffuse. And then what happens is, which one travels further, the lighter one or the heavier one? The lighter one travels further because it's traveling faster. And so what happens is, when it gets to that certain point, then we're going to get a precipitate formed right here on the in the tube. And then what we could do is we could see how fast it moved over how much time, and we can find its rate. All right. So the rate of diffusion of a particular gas was measured to be 24.0 milliliters per minute. So the rate of my unknown is 24 milliliters per minute. The rate of methane is 47.8 milliliters per minute. What is the molar mass of my unknown? So our equation is rate light over rate heavy is equal to the square root of the molar mass of my heavy over the molar mass of my light. So what is the rate of my lighter one? Lighter moves what? Faster or slower? 47.8. The lighter one, because it's, think of those miles per hour. 47.8 over 24 is equal to the square root of x. We don't know the molar mass of our unknown gas. And the molar mass of CH4 is what? C is 12, H is 1, there's 4 of them. 16. Now you have to solve this. So where's my starting point in solving this? Square everything. So we square it and solve for x. So when you square this, what do y'all get? Somebody go do that for me. 3.97. And that is equal to x over 16. So x is going to be 16 times 3.97. 64? 63.5, and my unit is grams. You could be looking for the rate of diffusion.
How would you know which one was lighter and which one was heavier?
It might say you have a gas that travels 2 times faster than another one, and here's your molar mass. It'll give you a hint, yeah. Yes, lighters always move faster. Okay. If you want, there is the walkthrough on that. But now what we do is we can solve for molar mass another way, and we can modify perv-nert. So using perv-nert and density and molar mass and all this stuff, we can figure out what the molecular weight of a compound is, of a gas. All right, so somebody remind me what density is. D, yes, D, density, thank you. Density is mass divided by volume. So mass divided by volume. So this can be rewritten as molecular weight is mass over PV. See, this is density. Math is so wonderful. You can take all these equations and put them together. So this equation, how I remember this equation is I say, cats say what?
Meow.
Meow. So this is the kitty cat equation. So meow is equal to dirt over pee. Cats put dirt over their pee. So meow is equal to dirt over pee. Okay, so this is the equation I can ask you to solve for, giving you the density or molar weight, all this stuff to figure out what the mass of something is. All right, 22 degrees Celsius, pressure of 755 torr. Gas is found to have a density of 1.14. What is its gram formula mass? This is asking what is its molecular weight. So temperature is 295. Pressure is
755.
density is that's all we know. So molecular weight, so meow is dirt over pee. Meow is what we're looking for. Density is 1.14. R is 62.36. T is 295. And P is 755. So what is the molecular weight of my gas? 27.7 grams. Yes. Because it's in torr, so we'll use this number. All right, so you got to look at that pressure and determine which R you're going to use. Questions? All right, another problem. Let's find the density of one. What does the density of oxygen have if it's at 25 degrees Celsius and 745 torr? So temperature is what value? 298 K. Pressure is 745 torr. So we have dirt over P because we're looking for D. D is my X. What's the value of R? 62.36. T we said was 298. Pressure is 745. And what is the molecular weight? Oxygen gas is diatomic, so O2 is going to be 16 times 2 is 32. So what's the density of my gas? Everybody got an answer? 1.28. The unit is grams per liter.
How do you get into the calculator?
32 times 745. And then divided by, open parentheses, 62.36 times 298, close parentheses. I multiply these and then divide everything by this. All right, any questions?
No, ma'am.
All right, now we're going to go to stoichiometry.
Alright. Let's get it.
All right. The mass of a gas under STP is always going to be 22.4 grams or 22.4 liters. So if you ever see if you have 2 moles of a gas at STP, how many liters do you have? 44.8. If you have 0.5 moles of a gas, any gas at STP, what do you have? How many liters? 11.2. So any gas, it doesn't matter if it's hydrogen, helium, whatever, at STP, if you have 1 mole of it, it's 22.4 liters. If it is not at STP, then you've got to use PERVNER to figure out the information. To do the stoichiometry. And this will be one thing I put on the board tomorrow. The STP thing.
So that can go right.
You guys ready to do our last 2 problems? So, nitroglycerin is a liquid, and when it is detonated, it turns into 4 different types of gases. We get oxygen, nitrogen, water, and carbon dioxide. So those 4 gases are made from that one liquid. So what pressure will result from the detonation of 5 grams of nitroglycerin? So we have 5 grams of nitro. And it is sealed in 1 liter container. So we know the volume is 1 liter. And it has a temperature of 2457 Celsius. So we need to add 273, 2730 Kelvin. I want to know, what is the pressure that all these gases exert when that happens? So the first thing I need to do is I need to convert my grams of nitroglycerin into moles. So what we need to do is we are going to multiply that. For every 1 mole of this, we have, does anybody work this out? Is it 227?
Yep, for sure.
227 grams. So divide 5 by 227. 0.024. I'll say it there. Moles of nitro. So that's how much nitro, how many moles of nitro we're using. So when I use these moles of nitro, I want to know how many moles of gas is formed, all those gases. So what's the mole ratio of nitro? What's the number in front of nitro? What's the number in front of nitro? 5. In the equation. Oh, it's a 4. It's a 4. In front of the equation. Yeah, if you're looking at the notes, it should be in there. Okay, 4 moles. Yeah, the coefficient. Now, how many moles of gas do we make? We make 4 gases, right? And I want to know how many moles total do we make. So if I have 12 moles of carbon dioxide, and I add that to 10 moles of water, plus 6 moles of nitrogen, plus 1 mole of oxygen. What is that? 29. All those coefficients are gases. All those gases are going to exert a pressure.
Why are we only looking at the product?
0.174.
You missed. Never mind. Go on.
What do we get?
0.174.
0.174 moles of gas. All right, so I want to know what pressure those moles of gas make. So we need PV equals nRT. P, V is 1, N is 1.174, R is 0.821, and T is 2730. So what's the pressure exerted?
No. Yes. That's incorrect. That is incorrect. Still got 39.
Yeah, 38.
38.9.
39. Because you don't divide it by anything. 39. Well, I got whatever.
See, I got 60.
It's 39.
I got 39.
Okay, it's 38.9999142.
Yeah, that's why I got it.
Okay, give me 1 second.
Got it, come on.
Man, Brandon.
You have to divide? No.
No, you don't divide it by anything.
I mean, you could.
What, Sydney?
So we messed up somewhere because I don't think it's 39.
38.
Calculator's pretty small.
All right, so with the numbers we have 39, and the units are what? ATM. So all those gases together exert that much pressure. So that's why when you detonate a little bit of nitroglycerin, you have a big explosion because of all that pressure being exerted by those moles of gas. All right. It is.
Oh, my goodness.
Let's see. Are we right?
I don't think we are.
36. I think our number got skewed right here.
It's because we rounded to point.
We rounded, yeah. All right, last problem. One of the waste products of operation. So I want to know.
Are you recording?
I am. What mass of NO2 would result from the oxidation of nitric oxide at 27 degrees Celsius and 700 torr? So it's not a STP, so I can't use 22.4. So what I need to do is I need to do a mole conversion. How many liters did we have of nitric oxide?
65.
65. So we have 65 liters. And I want to know how many grams of NO2 will be formed. So the first thing I need to know is how many moles of the gas did we start out with? So we use Pervnert. The pressure is 700. The volume is 65. N is what we're looking for. R is 62.36. And T is 300. So how many moles did we start with?
Did I say 300?
Yes, 300.
What was the first number? What was the first number?
How did we get to 300?
Huh?
How did we get to 300?
27 plus 273.
Oh, okay.
Wait,
Yeah,
what
yeah,
was the first number? It's 2 point. It was either 45,500.
What did you get? 2.43 moles of NO. And I want to know how many grams of NO2 is made. So I need to stoich out from here to there. So what's the ratio of NO to NO2? So 2 moles of NO for every 2 moles of NO2. I need the molar mass of NO2. So 14 plus 32.
2.86.
For every 1 mole of NO2, 14 and 32, 46? 46 grams.
170.
So we get 111, so I want to say 112 grams of NO. NO? 2. So this should be, oh no, that's right. NO2 is made. Let's go through it and see if we're right. Toot. Walk you through. Oh. Whoa, wait, what? Slideshow. Is it going? Yeah. Okay. Anyways, I think we were right.
I think we're right.
All right.
Every kid will.
Your homework tonight is gas stoichiometry 1 through 5. And I looked through that and it looked like it was a bunch of PV equals nRT and not stoichiometry. And the true false 1 through 8, which will finish out that page.